All right, so what we've been looking at is how these four parameters, A, B, C, and D, affect the equilibrium price. Suppose we wanted to know how a change in one of the parameters would affect the equilibrium quantity. Then how would we proceed? We want to know how a change in one of the parameters will affect the equilibrium quantity in some market. How would we proceed to answer this question?
Take the partial derivatives using the quantity star.
Exactly. We have the quantity, the equilibrium quantity is given by this expression right here. It's equal to AD minus BC over B plus D. So all you have to do, as John has said, is differentiate Q star with respect to each of these parameters. Okay. And let's just as an exercise do that. What is partial Q star partial A? Take a minute to calculate this. It's good practice of your partial differentiation. What is this partial derivative right here? What rule of differentiation are you going to use to get that derivative? Okay, you could use the quotient rule, but actually there is a simpler rule to use. Whenever your the variable you're differentiating with respect to only appears in the numerator, then there will be a simpler way to do it. I'm having, tell me your name again, I've forgotten. What? How? What is the coefficient on A in this model? D over B plus D. You got a D up here, but you can't forget about this. Now D, B, and D and C are all being held constant. So you could just say, what is the coefficient on the parameter A? It's D over B plus D. But how? Let's go ahead. You may not see that on an exam. Let's just go ahead and see if we get the same answer if we use the quotient rule. Okay. So go ahead, Hal. What is the derivative of the numerator with respect to A? D. And what do we do with that D? Yes. So it's the derivative of the numerator with respect to A times the denominator, B plus D, minus what is the derivative of the denominator with respect to A? Times the numerator, which is this big mess AD minus BC, all over what, Hal? B plus D squared. So what does this reduce to? This is 0. Of course, it means this is all going to vanish. So our numerator just becomes just D over B plus D all over B plus D squared. Notice the B plus D cancels, and this simplifies to just D over B plus D, okay, which is the same thing we got this way. Okay. So both of these methods give the same answer. Okay, Hal, what is the sign of this partial derivative? Positive. Because D is positive, B and D are both positive, so numerator and denominator are both positive. So Hal, what does that mean? Exactly. That A and Q star move in the same direction. If A goes down, then Q star will go down. If A goes up, as you said, Hal, Q star goes up. They move in the same direction. Okay. Then let's just see that that makes sense. How would you represent that in a diagram, Hal? How would you show that diagrammatically? Right, so I'll draw my original demand, well, that has a vertical intercept of A, a slope of minus B. I'll draw my original supply. It looks like this. And here's our original equilibrium price. We'll call it P1 star. Okay, so that's our original situation. Now what happens, Hal? Yeah, and how does it shift? Yes, the intercept changes, and the intercept is getting bigger or smaller? Well, okay. Let's assume you're right, either one. So let's pick one. Let's take this case, Hal. You're exactly right. Let's assume that A goes up. If A goes up, then what happens to the demand curve? Yeah, it shifts upward. So let's say A prime is the new intercept, and A prime is up here. So now demand is shifting up, just as Hal said. Now, in this case, what happens to the equilibrium price? It goes up, because here's our original equilibrium, capital A. Here's our new equilibrium, capital B. Here's our new equilibrium price. So the demand curve shifts to the right, shifts upward. Oh, I'm sorry. I'm sorry. You're absolutely right. You know, I was just so used to doing price, I did it again. Thank you, Jonna. Okay, so instead of looking at price, we've got to look at quantity. Thank you, Jonna. Q1 star is our original quantity. Our new quantity is up here, Q2 star. So you're absolutely right, Jonna. We want to look at quantity, not price. Okay, I just had done so many examples with price, I did it again. Sorry. Thank you. Quantity, the equilibrium quantity, and parameter A move in the same direction. Okay. Partial Q star, partial A is positive. Okay. Let's just quickly get the other derivatives. What is, this will be a little bit interesting. How will you get partial Q star, partial B? What rule will we use for this? This is interesting because B appears in both the numerator and the denominator. So what rule of differentiation does this suggest that we use? The quotient rule. Okay. So if we're using the quotient rule, what is the derivative of the numerator with respect to B? No, we're differentiating with respect to B, not minus B, but what is the coefficient on B? Minus C. Okay? That is the derivative of the numerator with respect to B. It's minus C. Then we multiply that times the denominator, B plus D. Minus, what is the derivative of the denominator with respect to B? Ben?
1.
Exactly. Times the numerator, AD minus BC, over the denominator squared. Okay. All right, so let's see what we get here. This one's kind of interesting, isn't it? Let's see if we can simplify this numerator. We got minus BC here. We got a plus BC there. Okay, minus times a minus BC, that's going to be a plus BC. So those two will cancel. So this will just be minus CD. We take this minus C times the D. And then we have a minus AD. And that's it, because this BC here canceled that one there. Okay. Over B plus D squared. And let's just take out this minus sign in the numerator and write this as minus CD plus AD over B plus D squared. And actually, what else can we do with this? Is there anything else we can do with that? Well, let's just, yeah, I think that's about as much as we can do. That's enough, because we can see right now, let me erase this, that the sign of this is what? Negative. Because this is all positive, that's positive. You got your negative sign out here, that guarantees it's negative. So that means that B and Q star move in the opposite direction, which makes sense if you think about it, because as B goes up, what happens to the equilibrium quantity? It actually goes down.